This is my third video on Google Test and Google Mock platform. In this video, you will learn how to write mock classes and how to specify their behaviors with onCall and expectCall macro from Google Mock. We will also talk about a lot of more details such as GMock Actions and the structure of unit tests that use GMock. Hello guys, I'm back with one more video on Google Test and Google Mock platform. In this section, I will focus on mocking classes and functions using Google Mock. If you like my content, please go ahead and subscribe to my channel, like my videos, and share them with your friends. Google Mock is very popular and is widely used, and it's also very fun to work with, so let's get started. What are we covering? If you haven't watched my previous videos on Google Test, I highly recommend you watch them first and make yourself familiar with Google Test platform in general, which was described in the first video, and also the matchers in Google Mock and expect that macro, which was explained in the second video. In this video today, we will talk about expect call, onCall, GMock Actions, and some advanced topics related to Google Mock, which are necessary for mocking classes and functions. So our focus is only on this section today, and let's get started. If you want to code along with me and run the examples that I show you yourself, you can clone this repo. The link is in the description. This repo can be run in Visual Studio Code using Bazel. The instructions on how to install and use Bazel is provided in the README file for this repo. You can also watch my video here that explains how this repo can be used. As far as running the examples in this repo is concerned, you don't need to be worried about details of Bazel. I've written all the necessary rules in this repo already, and you can use them as a black box. Please notice that Google Test can be used not only with Bazel, but also with other builders such as CMake. However, the focus of this video is on Google Test itself, not on how you build it. So if you want to use other builder platforms, I will link that to you to read the documentation on how you can build it with CMake. Who needs Google Mock? If you work in the industry and you predominantly use C++, most probably you need Google Mock to mock your classes and test your classes. If you are a student, you probably need GMock if you're working on a large project, for example, your thesis project or your end of semester project. And finally, if you're studying for job interviews, you should be familiar with how to mock classes, either using Google Mock platform or other platforms. Let's talk about mocking classes and functions. In the previous video, I mentioned that a unit test is a piece of code that applies some inputs to the system under test, maybe a class, maybe a function, and it observes the outputs and makes sure the outputs are expected. Now, if you're checking a complicated class, chances are this class is communicating and depending on some other collaborators. For example, your class might be talking to a database. It might require compiling and linking to other libraries. And it can also call some APIs or RPCs of a remote server. So if this is the case and this is your system under test, that means for testing this system, I have to make sure this database is working, my internet connection is up and running, I can compile and link against these libraries, and also my server for remote procedure calls is up and running. And this is a lot to expect for testing. If you say this to any developer, this would be the face that they make, and it is very scary. You don't want to bring up a database, multiple servers, just to do a simple unit test. And in this video, we will learn how to change your face from this to this, which happens when you learn how easily you can mock these collaborators and replace them with something that is very lightweight. Once you replace them with their mock versions, you can do a lot of things. For example, you don't need your internet connection to be up and running. And also your unit test can not only observe the behavior and the state of your class or your functions here, it can also observe the behavior and the state of the collaborators. And as part of your test, you can basically examine everything that is happening around your system under test. So if you are a developer, you will hear this mock word over and over, and people mean different things when they talk about mocks. Sometimes it just means this unreal collaborators, and sometimes they have very specific meanings. Let's talk about that specific meaning. In general, when you replace your real object, your real collaborators with something that is not real, that something is called a test double. A test double can be a fake, a stop, a spy, or a mock. In this context, mock has a very specific meaning. Now, to understand what this specific meaning is, let's first mention that there are two fundamental methodologies for testing. The first one is called state verification. In the state verification, your unit test examines the state of these collaborators, maybe after applying the input to your system under test and observing the output of it. It can go ahead and observe the state of these collaborators and finally declare if the test passed or not. Now, in this methodology, state verification, these collaborators can be either a fake, which means just a simplified implementation of the real class. For example, I can simplify the implementation of my database. It's still a database, but it's probably more lightweight. Maybe I can run it on my own system, so it doesn't require internet access. And maybe it can just work for a limited applications. A stub is just an object which has the same interface as the real thing, but it just provides some canned values only for testing purposes. And finally, you can have a spy, which is really a stub with some more features for recording the state, which then will be examined by your unit test. The alternative to this methodology is behavioral verification. In behavioral verification, your focus is really at the interface between your system on test and the collaborators. And that's where the specific meaning of mock comes in, which is an object that replaces these real objects on which you can specify very accurately what methods of that object should be called or how those methods should be called and also what they should return. And our focus in this video using GMock platform is on this methodology and not on this one. Although you will see that using GMock, you can still write code in this methodology, but that is not our focus. And this one is what we are going to talk about in details. Now, in order to fully understand these two methodologies, let's see an example. Suppose I want to write a class that represents an ATM machine. So this is my ATM machine. And suppose my ATM machine talks to a bank server. For example, when you want to withdraw some money from the ATM machine, the ATM machine should talk to the bank server, make sure that I have enough money in my account. And if so, that money should be debited from my account. And finally, the ATM machine should return the money that I want. So at the high level, let's assume my ATM machine calls these functions of the bank server. And let's assume these are APIs that this bank server is providing. In order to withdraw some money from the ATM machine, the ATM machine first calls connect, then calls get balance, then calls debit, and finally calls disconnect. And it will return success. This withdraw function returns success if I have enough balance in my account. Let's go a little bit more in details. This is the class that represents a bank server, which, as you can see, is an abstract class and it's really describing the interface of my bank server. It provides functions such as connect, disconnect, debit, and get balance. And once I have this interface, I can define my ATM machine to have an object of this interface as a private method, and I can pass this or inject this object through its constructor. Once my ATM machine has access to a valid object of this type, then it can go ahead and use it in the withdraw function. It first connects, it calls get balance. If the balance was enough, it calls debit, and then it calls disconnect. And so far, we only have an interface. What if I go ahead and create a real implementation of that interface, and I call that Bank of RE server? Let's, for the sake of argument, assume that I get very rich and I have my own bank and it's real. So the ATM machine has to first make sure the internet connection works, and then it has to call these APIs that this bank server provides in order to be able to call its withdraw function. So what does this really mean? The implementation of this real bank server requires a database, a bunch of libraries, and probably a lot more. So let's say I implemented this in a file called re.h, and there's a class here called Bank of RE, which is inheriting from our abstract class, the interface bank server. Now, because this is a real class, it might have a lot of other dependencies, and it might actually include a lot of other files, which means that in my test, if I want to use that real bank server, I will have to include this file, and that probably means that I have to be worried about all of these dependencies here. And moreover, I have to be worried about my internet connection, and even worse, each time that I'm testing, I'm withdrawing $1,000, which means that each time I run this test, I will lose $1,000, which in the end might make me very poor. So this is all bad, and we're back to making this face, and we have to fix this. And the problem really happened because my ATM machine is now talking to this real bank, and this real bank is coming with a lot of heavy baggage. And what you really want is to move from this heavy baggage to something that is very lightweight using a test double, which, as we mentioned before, it's either a fake or a stop, or it's a mock version. So my ATM machine now, instead of talking to Bank of Ari, the real bank, now can talk to either a fake or a stop, or it can use a mock. And as I mentioned, our focus today is on this methodology. Let's look at the big picture one more time. I have an ATM machine class. It has one member variable, a private member variable of this interface type. And the idea is to have two implementations of this abstract class. One is the real one that is used in production, comes with a huge baggage. And the other is another implementation, and that is used only for testing. The way I wrote my ATM machine, I don't really have to change my code. I can use C++'s polymorphism to inject the class that I want. I can inject this class for production purposes, and I can inject this class for testing purposes. So let's focus on this and see how we can implement this class. If you want to replace your bank server with a fake, stop, or spy, what you have to do is to create a new class, call it stop bank server, for example, which provides the same APIs, and then use that in your unit test. Notice that here I created a stop bank server and I pass it or inject it into my ATM machine, and then the ATM machine inside the withdraw call can call its APIs. And if you did a good job in adjusting your bank server, the result would be a success and you can validate it using expect true. Moreover, as an option, you can check the status of the stop and verify if the state of the stop after this call is as expected. As I mentioned, this methodology is not the focus of this video. So let's move on and see how I can replace the bank server with a mock. When you replace the bank server with its mock version, your focus is at the interface between the ATM machine and the mock. So your test would look like something like this. You would write the things that you expect your mock to perform. For example, your ATM machine is expected to call the connect function exactly once. Also, it is expected to call the getBalance function with this variable as the account number, which comes from here, and then it has to be called exactly once. And also you can specify, if this happens, return the value of 2000. This allows withdraw with $1,000 to be a success, and finally return true. And similarly, you can specify what should happen for the rest of the functions that you expect to be called. Now let me show you a preview of how this would look like using Google Test. This was the outline of what should happen, and this is the implementation of this outline using Google Test, specifically Google Mock. So notice that here I'm using expect call macro to specify what calls are expected to happen: connect, get balance, debit, and disconnect. And also here I'm specifying what should be returned in response to get balance. Moreover, I am specifying how many times I expect these functions to be called. So connect should be called only once, get balance should be called only once, and so forth. And also notice that I created a new class called mock bank server, and then I injected this inside my ATM machine. Up next, we'll go over the details of these macros and what they provide, and also how to write this mock class. Let's get back to our big picture. I have an ATM machine class that talks to a bank server as a collaborator. And what I want is to have a separate implementation of this abstract class for production and another implementation as a mock, which then I can inject inside my ATM machine so that the ATM machine can call its functions and I can specify what should happen in response. The code here shows how you define your mock class. Defining a mock class using Google Mock is very straightforward. You just define your class, you inherit from your interface, and you use the mock method macro to specify specifications of all the API functions. For example, here I'm saying connect is a method whose return type is void. It doesn't take any parameters, and it is an override of the connect of the bank server interface. Similarly, getBalance is a function. Its return value is integer. It takes one parameter of type integer. It is a const as is specified here, and it's also an override of the original bank server interface. Having this mock bank server defined, then in my test, I can use it and I can instantiate it and pass it to my ATM machine. Notice that the only dependency for my unit test is dependency on this file, which is just a single class definition with declaration of its functions. I include the Google Mock header file, and also I include my interface class. Notice that this is just an abstract interface class, and usually this doesn't have heavy dependencies. You can run this example yourself from this path in the repo, and in fact, let me quickly show how this can be run and observe the results. If you go in the repo that I provided, the link is in the description, you will see all the definitions that we were talking about. The bank server is inside this file called bankserver.h, which is just a single definition of the class interface. The ATM machine is defined in this file, and it only has one method called withdraw and a constructor. The constructor takes one parameter, which is of type bank server interface. My mock class simply inherits from bank server defined here and specifies the specification of each function. Having this defined, I can write my test and instantiate an object of this class and pass it to my ATM machine. And notice that because I haven't specified what my mock is doing, the result would not be true, and I have an expect false here. So basically my withdraw, because I haven't specified what should happen as a result of these calls, my withdraw will fail and I will get a false result. Now, in order to run this, just type Bazel test, the path to this file without the .cc extension. This file in this repo is under test, GMock demo, and then unspecified. Once you run this, and if everything goes well, you will see that this test is passing. In order to see the output of the test, you can just type code Bazel test logs and then the path to this test followed by test.log. So here I'm trying to open this file inside Visual Studio Code. Once you open this, you will see that the test is passing. However, you will see a lot of warnings like this. Please don't worry about these warnings for now. I will get back to them and explain them in details. What matters now is that we were able to run a test and the test passes. So that was a great progress. Now we know how to run a simple test, and now we know how to create a mock class and provide it to our ATM machine so that our ATM machine can at least run. However, we saw that the result is false and we are not really able to withdraw. Now, before I tell you how this can be fixed, let's focus and talk about this macro in more details. Mock method takes several parameters. The first one is the return type, as we saw before. The second one is the method name. And the third parameter is the list of the argument types. And the last parameter is the specifications of your function, which can be const, override, or no except. These are C++ keywords which can specify extra information about your functions. For example, in this case, I'm saying my getBalance is a const function, is a const method, and it's an override of the parent class bank server. One thing to notice is that this is a preprocessor macro, and preprocessor macros come with a limitation. For example, if your return type is something like this that has a comma inside, it can't be compiled because the preprocessor cannot understand that the whole thing is the first parameter. Similarly, notice that one of the arguments of this function is of type stdmap, and the whole thing would not compile because this comma would be confusing for the preprocessor. This has two solutions. One is using a lot of parentheses, basically putting each of these problematic values inside parentheses, like here, or using an alias. With C++ using keyword, you can create an alias for any type and then use that alias inside your mock method, which doesn't have a comma. All right, let's get back to our example. We had a bank server interface. We created a mock class. We used it in our test. However, withdraw is not successful because we still haven't specified what should happen when the withdraw function is calling any of these APIs. So let's talk about that next. Specifying what the mock should do. Remember that inside the withdraw function, we are calling the bank servers connect, getBalance, debit, and disconnect. And we basically have to specify what should happen as a result of these calls so that the test can work. There are several things that you can do for specifying what should the mock do. One is simply just not specify it as we just did right now. The other is to use the onCall macro. And finally is to use the expectCall macro. And in your test structure, this is the place to specify what should your mock do. You either don't specify it as we mentioned before, or you use the onCall macro, or you use the expectCall macro. Once you specify what each method of your mock should do, then you can go ahead and start your test. So what are the differences between these three alternatives? If you don't specify what should happen, no surprise, a default thing will happen. Which means if your function returns void, it just returns. If your function returns Boolean, it returns false. And for all other built-in types, it returns 0. And for a user-defined type, it returns their user-defined default constructor. If you use the onCall macro, you can actually specify what action should be taken. For example, you can return a value, or you can do a combination of actions. ExpectCall does the same thing that onCall does with a little bit more. First of all, when you use ExpectCall, the call that you're specifying will be verified, which means the test expects that call should happen. If it doesn't, that would be an error. This is not the case for onCall. You can specify what a mock function does. However, if you use onCall and that function that you specified is not called in your test, the test will not fail. Besides this, ExpectCall can do many more things. For example, you can specify the order of calls, the number of calls, and so many more things, which we will talk about in detail next. So let's go back to our example and see what happened when we didn't specify the calls. We just mentioned that if you don't specify a default thing will happen, most of our functions are void here. The important one is getBalance, which, because we didn't specify what should happen as a result of its call, a default value of 0 will be returned, which means in withdraw function, our ATM machine will think that our current balance is 0. And obviously, you cannot take $1,000 from an account that has 0 value, and the test fails. Up next, using the onCall macro. If you use the onCall macro, you can actually mention that if on my mock bank server, which is the mock object that we created, if the getBalance of this mock object is called with the parameter of account number, which is 1, 2, and 3, then return $2,000. So of all the functions that are called, we only specified this one, which is the most important one. And when the $2,000 value is returned, the ATM machine will think that we have enough money in the account and it can withdraw, and therefore the result will be true, and we can verify it using expectTrue. Notice that we only specified getBalance. The other functions are void, and if you don't specify them, it's okay. The default return would be just fine. You can run this code from this path yourself. Now let's look at the two cases of not specifying anything and using onCall macro side by side. By not specifying anything, as I mentioned, you're actually saying that the default values are okay, which is equivalent to using the onCall macro and specify the return values. So here I'm saying for connect, just return. For getBalance, return 0, which is equivalent to what the default value would do. And for debit, just return. For disconnect, just return. So these two tests are equivalent and the result would be the same. Now let's look at this case where we actually specified what should happen for getBalance and return 2000. Therefore, the result of the test is true. However, we didn't specify anything else, which is equivalent to actually have the onCall macro, but specify what the default value would do. So you can either include this default behavior or not include the default behavior. Now let's look at another example. In this example, I have two calls on my withdraw function. One is with the account number, the other is with the account number plus 1. And what I specified here is for getBalance to be called with the account number, and in that case, I return 2000. Everything else is default. This will work for the first withdraw function because we say if the getBalance was called the account number, return 2000, this would be a success and we can verify it right here. However, for this other function, our onCall specification would not work because we only specified what should happen with this parameter. So what should happen when getBalance is called with this parameter? And the answer is that it again falls back to default. The default value would be 0, and as a result, this value would be false, and you can verify it here. It's common to create a test fixture. Remember from the first video that a test fixture is a class that you inherit from Google Test's test class, and it has a setup function which runs before any test. So I can put onCall and specify what should happen for my getBalance. And in this case, I'm saying if getBalance was called with any parameter, return the value of 1000. Having onCall in setup, I don't then have to specify it in my actual test, because what happens is that this function will be running before my test. While this is common, a lot of developers don't really like this pattern because you can't fully understand what test is doing without looking at the setup function. Now let's focus on what else does this onCall macro offer. This shows the general form of the onCall macro. It takes the mock object as the first parameter, and the second parameter is the name of the mock method, followed by its arguments. Now for its arguments, you can use GMock matchers. Remember GMock matchers from the second video. If you don't remember, I will show you guys some examples, but for details, please refer to that video. For example, here, I'm specifying an onCall macro, which which says that if getBalanced was called with any parameter, underscore is a matcher that can match to any value, and in that case return the value of 2000. Also here I'm saying if getBalanced was called with a value that was greater than 1000, only then return 2000. So if onCall is called with any other value that is less than 1000 or equal to 1000, this will not work and we again fall back to the default. Here is another example. Using matchers, we are specifying that if getBalanced was called with a value that is greater than 1000 and less than 2000, remember all of is a matcher which forces these two matchers to simultaneously be satisfied. Now besides the matchers in the parameters of your method, there's another form of matchers that you can specify with onCall, which is using .with. The matchers here work on each parameter separately. The matcher that comes here specifies something about the argument with respect to each other. And the type of this matcher is of type std tuple. So let's see how this works. The Google Test platform provides some multi-argument matchers outside of the box. For example, EQ is used to see if two arguments are equal to each other or not. Let's see an example of these matchers. Suppose my interface has this function called double transaction, which takes the account number and two values to be credited or debited to this account. Using the mock method macro, we can mock this as shown here. Now using onCall, you can say if double transaction is called with any parameters, notice that it takes 3 parameters, so I'm saying with any parameters that it was called, using .with, I'm specifying take parameter 1 and 2, so parameter 0 is this, parameter 1 is this, and parameter 2 is this. I'm saying if parameter 1 was greater than parameter 2, only in that case return true. In this other example, I'm saying if double transaction was called with any parameter, using .with, I'm specifying take argument 0 and 1 and make sure argument 0 is greater than 1, and also take argument 1 and 2 and make sure argument 1 is greater than 2. Again, all of forces these two to be satisfied at the same time. If this happens, if both of these two are satisfied at the same time, only then return the value of true. And finally, the last part of onCall is will by default, which means that anytime that this function was called, do this action. We will talk about the action in details in a few minutes. Up next, let's talk about expectCall macro. We talked about onCall, and now let's see what is the difference between expectCall and onCall macros. Let's put them side by side to see what's the difference. Here I'm saying when getBalanced was called with account number as its parameter, return 2000. And later inside my withdraw function, the getBalanced function is actually called with this parameter, for which the mock is actually returning 2000, and therefore the result of my test would be true. On the right side, using expectCall, I'm saying a very similar thing, which is expect that getBalanced is called with account number as its parameter. Optionally, I can mention that expect this call is called at least one time, for which return 2000. And similar to before, inside withdraw, getBalanced is actually called and we return 2000 for it. So they do similar things, but there is one important difference, which is the actual call to getBalanced with onCall is not verified. However, the actual call to getBalanced with expectCall will be verified. What do I mean by this? On the left, we are saying if getBalanced was called, return 2000. But if it wasn't, nothing bad happens. It's not the end of the board. The test should not fail. On the right side, we are saying the same thing, but we're saying getBalanced should be called at least one time, and if this doesn't happen, the test should fail. In fact, if you go ahead and comment out these lines here and here, on the left, the test still passes because all we said is that if getBalanced was called, return something for it. However, if we didn't call it, nothing bad happens. The test doesn't have any reason to fail, so it will pass. On the right, however, we are saying getBalanced should be called at least one time, and then if it was called, return 2000. So if for any reason getBalanced is not called, which is the case, the test will fail. This is the most important difference between expectCall and onCall. Naturally, the question would be, should I use onCall or should I use expectCall? And it all comes down to what exactly you are testing. If your test is mainly focused on this function being called, then yes, you should use expectCall. But if you're testing something else, and that's not the main focus of your test, maybe using onCall is better so that it makes your test less restrictive and easier to maintain. Moving on, let's focus on expect call and see what exactly it is providing. Again, let's look at their general form side by side. This is onCall and this is expect call. Notice that it provides a lot of other things compared to onCall. In the following, we'll go over all of these features and we'll talk about them one by one. First thing first, notice that expect call also provides matchers for the mock parameters. And just like onCall, instead of specifying what the actual parameter is, I can use a matcher. For example, an underscore matcher will match every parameter. Here, I'm saying that only when the getBalance was called with this account number value, return something. On the other hand, here I'm saying whenever a getBalance was called with any value, do the following. Here is an example of a complete test for our ATM machine with underscore. So first I'm saying that expect connect to be called, then getBalance should be called with any parameter for which returns 2000, and then debit should be called with any parameter. Finally, disconnect should be called. And now when withdraw is called, because I provided 2000, I should see the result to be true. And you can run this example yourself from this path. Here is another example with matchers. I'm saying expect that debit should be called with the first parameter being anything and the second parameter being less than 10,000. In my second video, I also talked about composite matchers, for example, all of, which forces both of these two matchers match at the same time. What we really say here is that if getBalance was called with a parameter that was simultaneously greater than 1000 and less than 10,000, in that case, return 2000. This is another way of specifying that my function can be called with any parameter. Rather than using underscore, I just provide the name without any parentheses or any parameters. This will also work, and what we are saying here is that if getBalance was called with any parameter, then return 2000. And you can run this again from this path. Similar to onCall, expect call has .with, which takes a multi-argument matcher. And as I mentioned before, using these matchers, you can enforce something on your parameters with respect to each other. For example, here I'm saying that expect debit to be called with any parameter values. However, the first parameter should be greater than the second parameter. For example, here I'm saying expect debit to be called with any parameter values. However, the first parameter should be greater than the second parameter. Up next, let's talk about cardinality. In using expect call, you can actually mention how many times you expect this function to be called. For example, here, I'm saying I expect getBalance to be called 10 times and the first time return 1000. I can specify what should happen when this function is called using will once or will repeatedly. I will go over these two shortly as well. Here is another example. I'm saying expect that getBalance is called at most 10 times and the first time return 1000. So notice that for cardinality here, I can use the following. Any number, at least, n, at most n, between m and exactly n are the things that you can specify here. So let's talk about will once and will repeatedly by looking at some examples. Here, I'm saying expect getBalance to be called with account number as a parameter at most 10 times and the first time return 2000. So here will once means the first time return 2000. And notice that we don't specify what should happen for the other calls. Here I'm calling withdraw 2 times. So the first time I specified 2000, the second time I didn't specify, and you guessed it right. Once you don't specify, we fall back to default and the value returned would be 0. So the result of the second withdraw call is false and you can verify it here. You can run this example yourself from this path. Let's look at this example. Here I'm saying getBalance is called at most 10 times. The first time return 2000, the second time return 3000, and if it was called again, I didn't specify it, so for any time after, we again return default. Here I'm only calling withdraw twice. The first time it returns 2000, the second time it returns 3000. So notice that will once is used to specify what happens each time. The first will once specifies what happens for the first call, the second one specifies what happens for the second call, and if you don't specify the rest of them, it falls back on default. Let's look at this example. Here I'm saying expect that getBalance is called at most 10 times. The first time return 2000, any other time afterwards return 3000. So rather than not specifying what should happen after this, I can use will repeatedly, which basically specifies what should happen after all of my will onces are used. In this case, I'm calling withdraw twice. The first time it returns 2000, the second time and any time after it returns 3000, and hence I can verify the result of both calls to be true right here. What happens if you don't specify the cardinality? The Google Test Platform documentation gives us a recipe on what will happen. Let's see each case in an example. So in this case, I don't have cardinality and I don't have will once and will repeatedly. Therefore, the cardinality is assumed to be once. So what am I saying here? I'm saying expect that get balance is called only once. And because I haven't specified what should happen in return, the default value will be returned. So the default value is 0. My withdraw should fail. On top of that, because the cardinality is expected to be 0, the second withdrawal will also fail. Even if it was returning true, the test fails because here I mentioned that expect get balance to be called only once. Let's look at this example. Here I'm saying if get balance was called with this parameter once, the first time return 1000. And I don't specify what should happen next. Using the documentation, this falls under the second category, which means that the expected number of times would be exactly one call. So if I go ahead and call this withdraw again, the test will fail because get balance was expected to be called only once, and now it was called twice with exactly the same argument. Now let's look at this example. In this case, I don't have the cardinality, I don't have dot times, and I have will repeatedly. So here I'm saying get balance, if it was called with account number, should always return 2000. And this falls under the third category, in which case the cardinality is at least 0. So here we are telling Google Test Platform that we expect this call to be called at least 0 times. Therefore, if you go ahead and call withdraw twice, it wouldn't fail the test because it's expected that this call is being called at least 0 times, so 0 or more, and you can verify that both of these two results are true. Again, you can run this example yourself from this path. This example shows how you can disallow a call. Here, I'm saying expect debit with any parameter to be called exactly 0 times. And previously, I mentioned get balance to be called exactly once, for which you return 0. That means when I call withdraw, it sees that I don't have enough balance, so it shouldn't attempt to call debit. Therefore, I added this expect call, and I mentioned to double check that debit is not called at all. You can run and play with this test from this path down here. So this was one way of disallowing a call and telling GMock that if this function debit was called with any parameters, the test should fail. There is one more way to do this, which brings me to the next topic, which is called uninteresting calls. Remember from the beginning of this video where we looked at the output log of your test and we saw these warnings, and back then I promised to go over these warnings later. This is the time to talk about them. So what is happening here is that what we specified was only expectation for get balance call. And as you remember, the withdraw function of the ATM machine is calling connect, get balance, debit, and disconnect. Of all these three functions, we only specified get balance. The other ones, debit, disconnect, and connect, are left unspecified. If something like this happens, that is, if one of your mock functions is being called without any expect call for it, you will get a warning of uninteresting call. And the Google Test Platform is mentioning that it looks like you were not interested in these calls. However, they were called and we get a warning just so that we didn't make any mistakes. Let's look at the output log of this test. In the output log, you see that there are 3 warnings, one for each unexpected call, namely connect, debit, and disconnect. These are the calls that we did not specify any expect call for them, and that's why you get a warning. One way to make those warnings go away is to specify one expect call for each mock method that is being called as a result of withdraw. If you specify all of these functions, then there will be no warning in the output and your test will pass. You can check this from this path down here. There is one more way to suppress the warnings for uninteresting calls, which is by using NiceMock and wrapping your mock object inside this template that is provided by the Google Test Platform. If you wrap your mock object inside NiceMock, you will not get any warnings for uninteresting calls. If you leave it as is, if you don't wrap it, then you get uninteresting call warnings. And finally, if you wrap it inside StrictMock, again provided by the Google Test platform, these warnings will be converted to failure. And basically, if there is any unexpected call in this test, the test will fail. And this is another alternative for disallowing unexpected calls. So if you want to disallow all the calls except for the ones that you specify with expect call, you can use StrictMock. Notice that NiceMock and StrictMock only affect uninteresting calls and not unexpected calls. What does an unexpected call mean? An uninteresting call is the call for which you have not even a single expect call, as we saw in the previous example. An unexpected call, however, is that there is at least one expect call for this method. However, that expect call does not match the actual call. What am I saying? Let's look at an example. Let's go back to our ATM machine again and only specify get balance. However, notice that the expectation on get balance is with parameter 1234 as a count number, but our withdraw function is passing 5678 as the account number. So these two parameters don't match, and the get balance that is called inside withdraw will not match this get balance. And that makes get balance an unexpected call because we do have an expect call for it. However, the parameters don't match. The other calls, connect, debit, and disconnect, for which we don't have any expect call, are categorized as uninteresting calls. And finally, the expected call is get balance with parameter 1, 2, 3, and 4. Unexpected calls are always an error. So if you have any unexpected call in your test will fail, including the one that I'm showing right here. And that is probably fair because on the one hand, you're saying expect a call with this parameter and the actual call is a different parameter. So something must be wrong. Up next, enforcing the order of calls. As you specify expect calls for different methods of your mock object, you can also enforce and have GMock to check the sequence of these calls. This can be done in 3 ways. The first way is to use .inSequence from expect call. The other is to use .after, again from expect call. And finally, the last one is using the inSequence class. So let's look at method number 1. Suppose my mock object has 3 methods, A, B, C, and D, and we want to enforce this sequence. B should be called after A, and then C should be called after A, and D should be called after C. In order to enforce this, you should create an object of type sequence and assign each path inside this graph to one of these objects. So here I have S1 and S2 as 2 sequences. S1 represents this path and S2 represents this path. And in order to assign these calls to each sequence, you just use .inSequence. For example, A participates in both sequence 1 and sequence 2, and that's why I have them as 2 parameters of inSequence. And B participates only in sequence 1, that's why we have S1 here. And C and D only participate in sequence 2, that's why we have sequence 2 here. The combination of the order of these expect calls and the fact that they are assigned to these sequences will enforce this order. For example, because expect call of D appeared after C and they are on the same sequence, that means GMock will make sure that D is happening after C, and if not, the test will fail. Let's go back to our ATM machine example. And suppose we want to enforce that disconnect always should happen after connect. In order to do so, we create an object of type sequence and we assign it to both connect and disconnect using .inSequence. Once you do this, if inside withdraw, disconnect is called before connect and not after that, the test will fail. You can check this test yourself from this path down here. Up next, .after. This is an alternative method for enforcing the order of your mock object's methods. Again, back to this example. Suppose you want B to happen after A, and C happen after A, and D happen after C. In order to do this, you can store the return value of expect call inside a variable of type expectation, which is provided by the Google Test platform. So I'm storing the result of this expect call inside the variable A, and then in the expect call for B, using .after, I provide A. This will make sure that B is being called after A, as we specified inside this graph. Similarly, C should happen after A, and also D should happen after both A and C. So this is yet another way to specify the ordering, and notice that this dot after takes various parameters of the things that should happen, of the calls that should happen before this call. Dot after normally takes 5 parameters at most. If you want to specify more, like for example, if you want to specify call B happening after these many calls of A, you can store the result of all of those expect calls inside an object of type expectation set, again provided by the Google Test platform. And in dot after, just specify this set rather than specifying each expectation separately. Going back to our ATM machine, let's say we want to enforce that disconnect is happening after connect and debit. In order to do so, we store the result of expect call for connect and debit inside a variable of type expectation. And when we are specifying disconnect, we mention that it should happen after connect and debit. This will enforce this ordering, and if it doesn't happen, then the test will fail. And finally, let's talk about the last option, the last method for enforcing the order of calls. And that is by using the inSequence class. Notice that in my simple test, as I specify expect call for each of these functions, inside withdraw, these functions can be called with any order, and as long as the parameters match, the test will pass. It doesn't matter in what order withdraw is calling these functions. However, if you create a class of type inSequence, as long as this object has scope, which is inside these two curly braces, it will enforce the sequence of the calls in the order that they appear. So in this case, the test will fail if these functions of our mock object are not called inside withdraw in the same order that they appeared here. Namely, getBalance should be called after connect, debit should be called after getBalance, and disconnect should be called after debit. So this is probably the easiest way to enforce this sequence. Using this method, you can also create partial orders. For example, here I'm creating 2 scopes. In the first one, I'm enforcing disconnect to happen after debit, and in the second one, I enforce that getBalance happens after connect. As long as this ordering here and the ordering here are observed by withdraw, the test will pass. Up next, GMock Actions. We have already talked about what should happen if our mock method is being called, and we previously specified that using return. It turns out that there are various other actions that you can specify, which are listed here. The first one is doing the default action, or returning something, which is something that we have already seen, or performing some side effects, or invoke a function. And finally, if none of these work for you, you can create a custom action. Let's go through these one by one. And let's talk about do default first. Suppose I write a test fixture where inside the setup function that is run before each test, I use onCall and specify that if getBalance was called with any parameter, return 1000. Now inside my test, I can say expect the call for getBalance with this parameter. Once this happened, do the default action. And the default action means what I specified with onCall. So I'm not really specifying anything extra here. I'm just saying to expect this call, and as a result of this call, do what I told you to do before. Compare this with this case. For this test also, the setup will be called and the onCall is already specifying what should happen. However, expect call is overriding what should happen by saying return 2000 instead of 1000. So rather than deferring what should happen to the default, it overrides it. And that's basically the usage of do default. Up next, let's talk about return. We have already seen what return is doing. For example, here for getBalance, we're returning either 1000, 2000, or 3000. There are various other forms of return, which I invite you to look at the documentation for the details. However, I will show you guys some examples. In this example, I am saying call withdraw 3 times. And in expect call, we say that expect getBalance to be called with account number as parameter, which matches this one. And the first time, return 2000, then 3000, then 4000. And if it was called again, go back to 2000 and keep returning these values in a round robin fashion. And you can do this with return round robin. Here is another example in which we have a pointer that is pointing to a variable called current balance. Having this defined, then I can say when getBalance was called, return the pointee of this pointer, which is what it is pointing to, which is get balance, which is the value of 10,000. Here I'm saying when get balance was called with this parameter, return the parameter number 0, which is this parameter itself. So the first time I call the pointee, the second time I'm returning the argument 0 itself. And finally here I'm saying for the next calls, return the current balance itself. You can play with this test yourself from this path down here. Let's talk about side effects. Side effect means once this function gets called, do something on the side, which doesn't necessarily mean returning something. For example, here I'm specifying expect call for disconnect, and what I'm saying is that as a result of this, once this function was called, assign the value of true to this variable done, which is first set to false. So as soon as this function is called, the value of done will become true. Again, there are various things that you can do with side effects. I invite you to check the documentation for details. However, I will show you guys various examples next. In this example, I have two variables that are not initialized, account number and value. And here I'm saying once debit was called with any parameters, take the first parameter, argument 0, and store it in account number. And take the second parameter, argument 1, and save it inside the value variable. And do all just means do both of these two actions. So once debit is called, account number should be equal to 1234 and value should be equal to 1000. And you can verify this using expect EQ after your withdraw call. And finally here, I'm saying when disconnect was called, assign true to done, which was previously false. And you can also verify this using expect true. You can check this test yourself from this path down here. Here is another interesting example in which we set the value of error number variable, which is defined inside error number.h, and you can access it. So first we set it to 0, and here I'm saying when get balance was called with this parameter, set error numbers variable to error invalid and return 0. So set error number and return does two things. It assigns this value to this variable and it returns 0 as a result of get balance. If we return 0 as our current balance, the result of withdraw should be false, and that's what we are checking here. And also the new value of error number should be error invalid, which we are checking here. And finally, here is another interesting example that shows how you can specify that if one of my mock functions is being called, throw an exception. So here I'm saying when connect was called, throw an exception of type invalid value exception. And you can check if this exception is happening using either expect throw or expect that we talked about in my previous videos. So here using expect throw, I'm checking if withdraw function will throw an exception of this type. So this check should pass. And here using expect that, I'm saying exactly the same thing, but inside a lambda function. And here again, I'm doing the same thing. However, I'm also checking that the message for that exception is equal to invalid value. Again, you can check this test and run it yourself from this path down here. Up next, invoking a function. Sometimes as a result of the call, I want to invoke another function. And not only that, I want to pass the parameters that was passed to this mock method to that function. Let's see an example. So here I define a function square that takes one parameter and returns x to the power of 2. Having this defined, I can say when getBalance was called, invoke square and pass exactly the same parameter that was passed to getBalance. So as a result of this, when getBalance is called with this value, the return value would be 123 to the power of 2. Because here I'm saying call square and pass it the same parameter that was passed to getBalance. There are various forms of invoke, and again, I invite you to check the documentation for details. However, I will show you guys some examples. It is also important that when you have invoke, after the invoke, the return value would be what invoke is returning. Let's look at this example. I define 4 functions, print hello, square, sum, and return 10,000. Having this defined, now I can say when getBalance was called, the first time invoke square with the same parameter. And that will return account number to the power of 2. You can also use this shorter form and just provide the function name without invoke. It will have the same effect. For the next call, I'm saying do all of the following. Invoke without any arguments, print hello, because print hello doesn't take any arguments. That's why I use invoke without arguments. And also return 1000. So when getBalance is called for the third time, we not only return 1000, but also print something in this function that doesn't take any arguments. For the next one, I'm saying invoke this lambda function, pass to its parameter the same parameter that was passed here. And inside the lambda function, I'm saying use this parameter and return the squared value, which effectively does the same thing that these two are doing. Up next, I'm saying for the next call, return the sum of this parameter, which is the same as this one, and 1000. So this function will be called, it takes two parameters. The first one is n, which is the parameter of our lambda function, which is the parameter that was passed to getBalance. And we just return n plus 1000. And the last three are different ways of specifying return 10,000 once the getBalance was called. You can either call it in a lambda or just bring the name or use return and then return the result of this function. And finally, here is an example that shows when debit is called with these parameters, take these two parameters, pass it to this lambda function. So A would be account number, W would be withdraw value, and just print this. So all I'm saying is that expect debit to be called, and once it is called, just print the value of these two arguments in the output log file. Up next, composite actions. We have already seen the do all composite action to specify that two actions should be called as a result of this mock methods call. So here I'm saying once debit was called with any parameters, take the first parameter, argument 0, and store it inside the variable called account number. So I'm saving argument 0 inside this variable. And here I'm saying save argument 1, which is this one, inside this variable. And do all just means do both of these two actions. Here are other composite actions. Again, I invite you to look at the documentation for details. However, I will show you guys some more examples. Suppose I have a mock method that takes 4 parameters. And my goal is to multiply the second parameter and return that as a result of this call. So I can say expect this method to be called with any parameter. Once that was called, take argument 1, which is the second parameter here, pass it to the function that this invoke is specifying, which is a lambda function that takes one parameter, namely the one that we specified here, and multiply that by 2 and return it. So if I call this function with these parameters 1, 5, 1, and 1, the return value would be 5 multiplied by 2, which is 10. And that is what you can verify here. Up next, writing a customized action. Creating a custom action is very easy and straightforward. All you need is to create a functor class and then you can use it. Remember, a functor class is a class that is defining this function operator, and it can optionally be a templated function. So here I'm saying I have a functor that its operator returns its parameter multiplied by 2. Now that I define this, I can then go ahead and say when my mock was called with any parameter, pass that parameter to this operator function and return its value, which is multiplied by 2. So the result would be if I call my mock method with 5, it should return 10, and if I call it with 7, it should return 40. Here is another example in which I'm defining a functor that adds up all of its parameters. There are 4 parameters, it adds them up and returns the value. So if I call this method that takes 4 parameters, here I'm saying pass those 4 parameters to sum of all, this method, and return the result of this method, which is the sum of all of these arguments. So if you call it with 1, 2, 3, and 4, the return value should be the sum of these values, which is 10. Up next, sticky rules and retire on saturation. So one thing that is probably a little bit different in GMock than other test platforms is that when you write expect calls, these rules will be sticky. That means if you call this function multiple times, all of your expect calls that specify anything about this function will still be active. And if you have multiple expect calls, GMock will try to match them from bottom to the top. What do I mean by this? Let's look at some examples. Here I have 2 expect calls which are specifying something about getBalance. This one says if getBalance was called with 1, 2, 3, 4, return 1000. This one says when getBalance was called with a parameter that was greater than 1, 2, 3, 4, return 2000. So by being sticky, that means for both of these withdraw calls, these expect calls are still active. What happens is that when the first one is being called, GMock will try to match getBalance inside this withdraw with the first expect call from bottom to the top. And it will see that the parameters match, and it has to be called only once, so it returns 1000, and it doesn't try to match it with this one. When the next one is called, again, it will try to match it from bottom to the top. It will see that this one is not matching, and it moves on to the next one, and it will see that this one would be matched because I have 5, 6, 7, 8, and here I specified that this value should be more than 1, 2, 3, 4, so there's a match, and it will return 2000, and everything is fine. The important thing to notice is that these two conditions did not overlap. The value is either 1, 2, 3, 4 or greater than 1, 2, 3, 4. These two do not overlap. Compare that to this case. These two now overlap. So I'm saying expect call one time and return 1000. And here I'm saying again expect call with the same parameter and return 2000. So when the first one is called, GMock will try to match this with this parameter. There is a match, and for that returns 2000. When the second withdraw is called, again GMock tries to match it against expect calls from bottom to top, and because our rules are sticky, it will notice that this will match the first rule again, but we mentioned that this should be called only once. Because this is the second call, the test will fail. And the problem happened because of two reasons. There is an overlap between these two expect calls, and GMock tries to match these parameters from bottom to the top, and it happens that this will be matched twice, but you mentioned this should be called only once. Let's look at this example. In this example, the situation is exactly the same, except that I use retire on saturation, which means that when the first one was called and it was saturated, this expect call was satisfied or saturated, retire this so that it's not sticky anymore. So when the second one is being called, GMock platform still tries to go from bottom to the top, but ignores this one because this was retired. So if you run this test, you will notice that it would pass and there's no problem with it. And you can try this from this path down here. However, I should mention that probably a better way to specify this would be combining them inside one expect call, and mention that for the first one return 1000 and for the second one return 2000. This is probably more readable and a preferred way of specifying what should happen for each of these function calls. Let's look at this example. So here I'm saying when getBalance was called with any parameter, return 2000, and when getBalance was called with 1, 2, 3, 4, return 1000. So the first one would be called. We try to match from bottom to the top. So 1, 2, 3 will match 1, 2, 3, and because there was a match, we return 1000 and everything would be fine. When the second withdraw is being called, again, GMock tries to match it from bottom to the top, and because this one doesn't match, it moves on to the next one. If there was a match, there would have been a problem because we mentioned that it has to be called only once. However, because there was not a match, GMock is okay and moves on to this one and sees that there would be a match here, and then it returns 2000. So this test will pass and there's no problem with it. However, compare this with the opposite case where getBalance with any parameter comes on the bottom and getBalance with a more specific parameter comes on the top. In this case, when the first withdraw is called, there's a match here because we say any parameter and then we return 2000. Notice that when withdraw is called with 5, 6, 7, 8, GMock will try to match again from bottom to the top, and notice that this would again be a match against 5, 6, 7, 8, and because we mentioned that expect call should be called only once, the test will fail. So the lesson here is that if you have a case like this where you want to specify a more general case and then a specific case, you have to bring the more general one on the top and the more specific one on the bottom because Google Test tries to match them from bottom to the top. So use this form, not this form. And also, if you can, probably specify everything in one expect call, which would make your test much more readable. Up next, GMock Advanced Topics. In this section, I will go over more advanced topics that you need to be aware from GMock. First, how to create checkpoints. Suppose in my ATM machine, I specify that the debit function should be called only twice with these parameters. And then I have multiple function calls to this function that takes a parameter, and only if the parameter was divisible by 10,000, it calls debit. And suppose I'm debugging my test and I want to know at what point after all of these calls, the debit function is actually called twice. I can do this by creating checkpoints. I can create a new mock class called checkpoint that has one function that takes a string parameter. Having this, I can create a mock of this object and enforce the following. Debit should be called with 1, 2, 3, 4 and value 10,000. Then check should be called with parameter 1, and then check should be called with parameter 2, and then finally debit should be called with 1, 2, 3, 4 and 10,000. This in sequence object forces the sequence of the calls to be exactly the same order that they appear, namely debit, check 1, check 2, and then debit. Now, if you go ahead and add your check calls after these functions, the test should pass, and if it doesn't, it should tell you exactly where the test passed. So here we are saying that first debit should be called, then checkpoint 1, nothing should be called between 1 and 2, and then checkpoint 2, and then debit again, which is exactly what we are specifying here. So in this call, because the parameter is divisible by 10,000, debit should be called, and then we call checkpoint 1, so this is also satisfied, and then these 3 should not call debit because the parameter is not divisible by 10,000, so this sequence of the calls is still satisfied by mentioning that nothing should be happening between these two checks. And finally, after this, checkpoint 2 should be called, and then this withdraw function is called again with 30,000, which then calls debit function to be called. So by adding this checkpoint here, if my test fails at this point, for example, I will know that up to this point, everything was executed correctly. You can run this example yourself from this path down here. Notice that here I created the checkpoint class myself. I could have used instead what Google Test Platform is providing. Google Test Platform provides this class called mock function that has exactly one method that is called call. So I could use this instead of creating my own class and call the call functions of this object instead of what I had before, which was check, and I had to create the class myself. So using mock function will save us from defining this class here, and the rest would be the same. Again, you can try this test as well from this path here. Up next, more details about mocking classes in Google Mock. How to mock private and protected methods. Remember that your class can have functions that are either public, protected, or private. If you're mocking these functions that are protected or private, you should also make sure that in your mock class, these are defined as public methods, not protected or private. Up next, mocking overloaded methods. Suppose in your class you have overloaded functions with different parameters, for example, the add function here. The way to mock this is no different than mocking other functions. You just list them in your mock class with the parameters that they take, and everything is as usual. Up next, mocking template classes. What if I have a class that is templated? How would you mock this class? And the answer is that it's so easy. Just create your mock class and make that also a template very similar to what you had here. So here I'm saying my mock class is inheriting from this interface, and it is a template class, and you pass this template parameter to what you are inheriting from, to the interface, and the rest is just like before. Up next, mocking non-virtual classes. Remember that in our first example, we had to have an interface class, which is a virtual class, and then we had two implementations for this abstract class. One is the mock class, which we inherit from this interface, and the other is the real bank, the real class that you also inherit from this interface. This one will be used in production, and this one will be used for testing. Remember that using dependency injection, we pass either this class or this class to our ATM machine. In particular, our ATM machine had one variable, one member variable, which was of type the interface, and in the constructor, we inject either the production class or the test class that inherit from the bank server interface. So that means if you want to test the class has to be virtual, and it has to be an abstract class. And this is one of the main criticisms that people have with the Google Mock platform, which is you can only test if your class is a virtual class. And it turns out that there is actually a way to mock non-virtual classes, and it's not too bad. So let's say our bank server, the real bank server, is not actually virtual, and I have a standalone class like this. And you want to mock this class without creating any abstract parent for it. And the way to mock this is to just write a mock class that doesn't inherit from anything and specify the same methods that we have in the real class. So what remains is to find a way to pass this one to our ATM machine for testing and this one to our ATM machine for production. And you can do this easily by making your ATM machine a template class. So rather than dependency injection now, I use a template variable, which is now defined here as my bank server. So in production, I can instantiate my ATM machine with the production version of the class. And in testing, I can instantiate my ATM machine with the test version of the class. And this allows me to test this class, which is not virtual, so I don't have to modify my code that much and create a parent interface for this. However, you do have to make your ATM machine class to be a template class. So let's look at how our test will look like. I defined my ATM machine to be a templated class. So when I instantiate my ATM machine, I have to pass the mock class as the template parameter. Now I can define my ATM machine and pass the mock bank server, which is of this type. Notice that this class doesn't inherit from anything. It just happens to be a mock class that has the same interface that the real class has. You can check this test yourself from the path down here. Up next, mocking a free function. How to mock a free or a standalone function. So far, we learned how to mock classes. What if I have one global function like this that I want to mock? And the way to do this is to wrap it inside a class. So I have to create a wrapper class like this, and that wrapper class has one virtual function that has the same signature as this class. And now I have to create two implementations for this interface. One is the real one used for production, which calls the actual global function. And one is the mock class, which is used by Google Mock. And the way to use this is to inject an object of this type through the constructor here and defining a member variable of this interface type. So now I can inject inside my ATM machine an object of this type for production and an object of this type for testing. Again, you can run this test yourself from this path here. Up next, how I can delegate to a fake object. Suppose besides the mock object for a bank server, I also create a fake bank server, which is similar to a real one with a more simplified implementation. And suppose under some conditions, rather than mocking the behavior, I want to delegate the action to this class rather than my mock object. And one way to do this is that inside your mock class, define an object which is of this type, your fake class, and create this method that says delegate to fake, which basically says when getBalance was called, then call the getBalance on the fake object rather than returning something yourself. So in my test, I can create my mock object and then call this delegate to fake whenever I want to enable delegation, which then causes the getBalance function inside withdraw to be delegated to this fake object and then return what this function is returning. So this is a great way to delegate the functionality to some other class if you don't want to bother with specifying what should happen in the mock class yourself. And this is useful when your mock is non-trivial or if you want to share it among multiple tests. And if you can delegate to a fake class, you can also delegate to a real class. Just like before, you can have your mock class have a member variable of the real class now. Using this delegate to real, I'm saying when the getBalance was called, rather than mocking it yourself, return what the real object would have returned. And inside my test, I can enable this delegation. And when getBalance is called here in withdraw, rather than specifying what the mock is doing, I can just delegate that functionality to the real object. Obviously, now my test is dependent to the real object. And finally, criticisms of Google Mock. I have showed you all the benefits and all the features of Google Test and GMock platform. However, it's worthwhile mentioning that GMock has been criticized by many people, and I think it would be educational to go over some of these criticisms. The first point is that GMock uses macros, and nobody likes macros, and especially we hate macros when it comes to debugging. If you have syntax errors that are related to the macros, they're usually very user-unfriendly and hard to understand. Moreover, using a combination of macros and functions, the way you write your test is not exactly C++. It's as if you have to learn a new language. And in some cases, for example, for matchers, you have to learn what each matcher is doing, despite the fact that an equivalent operation already exists in C++. Next, and probably the biggest issue that people have with Google Mock is that it requires creating virtual classes and interfaces. Remember that for our example, we had to create an interface for this bank server and then create two implementations of it, one for test and one for production. This is not ideal and it's not easy to do, especially when it comes to legacy code. Now, I showed you that instead of virtual classes, you can also use templates, but still you have to change your legacy code, and using templates can hurt your compile time. Moreover, I showed you that for testing free functions, you have to wrap them first in a virtual class and then create two implementations, which in all fairness is too much work for just testing a free function. So if you want to test legacy code using either of these methods, it requires you to modify your code, and we all know that modification of legacy code is not a very fun task. Next, the macros are confusing. For example, I showed you that you have a choice between onCall and expectCall. It's not always clear where I should use expectCall, where I should use onCall. And in fact, Google documentation itself mentions that onCall is underused and encourages you to use onCall if you don't need to verify your calls. However, on the other hand, if you do use oncalls, as we saw, you will see a lot of warnings in your output, which then I showed you to solve that using a NiceMock. And the other thing that is one of the quirks of GMock is the stickiness rule for expect calls that, as I showed you, can be very confusing. The other criticism is that GMock tests are very hard to debug and they can fail at multiple points. For example, if you look at this test, it can fail at any of these expect calls or when you are doing the assert for the result of this call. And as we know, there's a general guideline that tries to test one thing or very little things in each test. And if a test can break at multiple points, it's really hard to maintain and manage that test. Compare this test to the alternative when you're not using mocking and you're using a fake instead, which doesn't have these expect calls and can fail at only one single point here. Next, mocking creates a tight coupling between the system that you're testing and its collaborators. For example, in this test, we require the ATM machine to call these APIs. And if for any reason you change your system in the future, then you have to come back to this test and fix it. And it's even worse because it's not just one test, you have a whole test suite to fix, and that is, again, not fun. And finally, tests become too long and hard to read. If I have to write a lot of expect calls and oncalls at the beginning of my test, just for understanding what the test is doing, I have to go over all of these lines and understand each statement here, where if you have a lot of APIs and a lot of setups, then this test can become very long and very hard to read. And to GMock's credit, I have to mention that the last two items are not problems with GMock specifically, they are problems with mocking in general. And I also have to mention that the GMock and Google Test platform that you're using today has come a long way. And although we don't like macros and all the confusions here, what you see today is much more improved than what used to be a few years ago. GMock is widely used not just by Googlers, but also a lot of people outside of Google, and it's open source. And you can also go to its GitHub page and contribute and send a pull request. So the bottom line is that if you want to use mocking in general and use GMock platform, please make sure that you're aware of all of these criticisms before you start writing your tests. Before I finish, let's have a quick summary. So this was the third video in my video series on Google Test and Google Mock. In the first video, you saw how to write simple unit tests using Google Test platform. In the second video, we talked about Google Mock, but only the matchers and expect that macro. And in this video, you learn how to mock classes and functions using expect call, onCall, and also GMock Actions. We also talked about some more advanced topics such as forcing sequences, checkpoints, delegation, and how to create custom actions. I hope these videos were useful to you. Thank you very much for watching them. Please make sure to go ahead and subscribe to my channel, like this video, and share it with your friends. Hopefully, I will see you in my next videos, and thanks for watching.